In this lesson, we're going to go through and show you a couple of examples on how to solve rational equations. So important to understand that when you see the word solve, then a rational equation, you are being asked to give a value of x that makes this equation true. So the last line you're going to write is going to be x equals something, and you'll actually give a value. Now, when we're dealing with rational equations, that is, equations that involve fractions, a good strategy right off the bat is try and remove the fractions, that is, get rid of the denominators. So if we take a look at these two denominators, we've got a denominator of 3, another one of 2, and what we want to know is, is there a value that I could multiply every single term by, in this case there's only 2, that would allow me to cancel out these denominators. So you're looking kind of for the least common multiple. And if I look at 3 and 2, then 6 would be a good choice, and you'll see why. So if I take the value of 6, and I'm going to multiply the left side, so x plus 2 over 3, I'm going to multiply that by 6, and I'm also going to multiply the right side by 6. So I'll take my 6 and multiply the 2x minus 4 all over 2 times 6. Now how does that help us? Well, because we have joined these two terms by multiplication, that is the 6 and the x plus 2, I can cancel between the numerator and the denominator. We can always cancel across multiplication. So 3 divides into 6 twice, and on the right side 2 divides into 6 3 times. And what that leaves me with is 2 times x plus 2 equals 3 times 2x minus 4. And it's just on a side, it's kind of interesting to notice that that is exactly what we would have got had we cross multiplied these two terms across the equal sign. So where do we go from here? Well, we've got a monomial times a binomial, so we're going to have to distribute these values into the brackets in order to help us solve for x. So 2x plus 4, that equals 6x, and then minus 12. Okay, well at this point I realize that I'm dealing with a linear equation. There's no squares, there's no quadratic going on in here. So it's going to be very easy just to collect all the x's on one side and then move all the constant values to the other side and shoot for that x equals answer we're going for. So I'm just going to collect the x's on the left-hand side. It really doesn't matter. Some people like to collect the x's on the side where there are more of them so that they will stay positive, but I think we're talented enough to deal with the negative value, so I'm going to pull the x's onto the left, and we will get 2x. The 6x will move across the equal sign, become negative, minus 6x equals, and we've got negative 12, and when the 4 moves across, the positive 4 becomes negative 4. Okay, well 2x minus 6x is negative 4x, and negative 12 minus an additional 4 is negative 16. And that means that the value of x is equal to negative 16 divided by negative 4, where x is positive 4. Okay, so there's a nice sort of simple example to get us started. And the reason why I say it was a simple example is because if we look at the denominators here, they were just constant values. So it was pretty easy to come up with this value of 6 that we used to allow us to cancel out both denominators. Well, let's look at an example now that's a little more complicated, a little more involved, and it is this example. Okay, well, clearly we can see that we no longer have nice, simple, constant denominators. In fact, we've now got some expressions happening, variable expressions happening in the denominators, and these are truly rational expressions. And how do we handle that? Well, I notice that I've got a quadratic on the right-hand side here, this x squared minus 2x minus 24. So just to start out with, I'm going to see if this factors nicely, And I'm just going to rewrite the equation as x over x minus 6. We've got our minus 1 over x plus 4 equals 4. And let's take a look at this trinomial. It's a simple trinomial because there is a 1 in front of the x squared. So I just need two values that multiply to give me negative 24 and yet add to give me negative 2. And I think you can see that we're going to be lucky enough to find an x minus 6 and an x plus 4. Okay, and why did I say lucky enough? Well, if you look on the left-hand side, you'll see that those, in fact, are the two denominators that we show in these first two terms. So if we are going to solve this rational equation, again, a first step is let's try and remove the denominators. And how could we do that? Well, if we were to multiply each of the terms by actually this pair of terms, we would be able to cancel out the x minus 6 and x plus 4, and also cancel out both x minus 6 and x plus 4. We have to be careful that when we're dealing with an equation, something that has an equal sign in the middle, the equation is in balance. It's perfectly balanced. The left side equals the right side. So if we are going to make changes, that is multiply into the equation, we have to do the exact same thing to both the left side and the right side. So let's multiply the entire equation by x minus 6 and x plus 4. So we'll start over here on the left, and we will say I want x minus 6 and x plus 4 to be multiplied by this first term, the x and the x minus 6. And then I'm going to subtract, and again, x minus 6 and x plus 4. I'm going to multiply that by the second term as well, x plus 4. And that is going to equal, and you guessed it, same thing on the right side, x minus 6 and x plus 4. And what is that multiplied by? Well, the term that's on the left, which was 4 over x minus 6 and x plus 4. Okay, so because we have joined the x minus 6, the x plus 4, and the original term by multiplication, we can now cancel between the numerator and the denominator. So if we look at the first term, this x minus 6 in the denominator cancels very nicely with that x minus 6. The x plus 4, this cancels nicely with this x plus 4. And on the right side, the x minus 6 cancels with the x minus 6, and this cancels with that. And what we're left with is an equation that looks much simpler. Okay, you can see that a lot of the complexity has vanished. Now, we just have to be careful here. We've got an x plus 4 term and an x. So we're going to have to multiply this x by both of these terms inside the brackets. And if we had a value other than 1, we'd be careful to multiply both of these terms by 1. And we just have a 4 on the right side. So let's expand these out, get rid of the brackets, and write what we have left. So x times x is x squared. X times positive 4 is plus 4x. 1 times x is x, so we are subtracting an x. 1 times negative 6 is negative 6, and we are subtracting negative 6. So that's add 6, and then equals, and we've just got the 4. Okay, so this one's a little different. In the first one, we recognized that we had a linear equation, a degree 1. But this one is quadratic. We have a degree 2 here. So in order to find the solution to a quadratic, that is the roots, we have a different strategy. We need to move everything over onto one side of the equation and set the right side of the equation to 0. That will allow us to try and use factoring, perhaps the quadratic formula, and we can even use a roundabout method of completing the square in vertex form to also come up with a solution. So let's do that strategy and see what we get. So we'll keep everything on the left here. We'll have x squared. We'll combine some like terms. So 4x minus x is positive 3x. And then if we have positive 6, when this 4 moves over to the left, it will become negative, and that will mean we'll have positive 2, and then nothing remaining on the right side equals 0. Okay, so here we've got our trinomial. Now, does this factor nicely? And I believe it does. If you take a look, we've got a simple trinomial that I believe will factor nicely into. You need two values that multiply to give you 2, that will add to give you 3, and I think we can clearly see that is x plus 2 and x plus 1. Okay, what are the solutions? Well, two solutions. One hiding in here states that x would be equal to negative 2, and this would be true. This would be equal to 0 if x was equal to negative 1. Okay, our last check that we do. We have two solutions here. And what I want to do is I want to check to ensure that these solutions, if I place them back here into this original equation, that I don't run into any sort of problems with a denominator turning to 0, because we can't divide by 0. So if I have the root negative 2, and I substitute that back in here, it would be negative 2 minus 6, which is negative 8. That's okay. Negative 2 plus 4 would be positive 2. That's okay. And it won't cause a problem in here as well. Negative 1, similarly, negative 7 here, positive 3, no problem there as well. So both of these roots are valid. If we had a situation, for example, let's say one of the roots turned out to be, oh, I don't know, x was 6, and I look back in the top and I say, well, wait a minute here. If I was to put x equals 6 in here, 6 minus 6 would be 0. Then that root would be an extraneous root, an excluded root. We could not use it because it was invalid. Even though it popped out as one of the answers, it does not pass the test of a valid solution. Okay, so there are two examples that show you how to solve a quadratic equation. A strategy for linear equations when you get near the end, and a strategy for quadratic equations when you get near the end. Just be very careful when you are multiplying all of the terms by the same value and you're canceling. If you just pay attention to detail, you shouldn't have a problem.